So we've talked about adding and subtracting vectors. We haven't talked about multiplying them yet. And there's actually two different ways that we can multiply vectors. So the first method is called the dot product, and that's what we're going to talk about today. The second method is called the cross product. And we're not going to talk about the cross product yet until we get into angular momentum, a little bit later in the class. So for today, we're just going to talk about the dot product. And this is really, it's pretty simple. So the definition of the dot product is if we have two vectors, if we have vector A, that's just A1, A2, A3, all the way to AN. And if we have a vector B, that's B1, B2, B3, all the way to Bn. So these are n-dimensional vectors. Then we just define the the dot product as A dot B is equal to A1, B1 plus A2, B2 plus A3, B3, and the same for all the components up to AN, BN. But now let's notice something. Remember, A and B are both vectors. So notice though that when we multiply A and B, the result that we get on the other side isn't a vector anymore. It's a scalar. So that's why another name for the dot product is the scalar product, because we're taking two vectors, we're multiplying them, and we're getting something that's a scalar. So to understand, a little bit of what this means physically, let's just imagine we have something like A dot A. So we see that that's A1, A1 plus A2, A2, etc., or that's A1 squared plus A2 squared plus A3 squared. So in other words, if we take the square root of A dot A, we see this is the square root of A1 squared plus A2 squared all the way to AN squared. But this is just the magnitude of A. Right? So what the dot product is really doing is it's really, you can see how we really are multiplying a vector here. Because if we multiply A by itself, if we take A dot A, then we get the magnitude of A squared. We get A squared. And so that's what the dot product is. The other way to look at it is if we say that A is some vector like this, if this is A, and then B is some vector that looks like this, then we take the smallest angle between the two, right? Because there's two angles between these vectors. There's theta and there's phi. The dot product is also defined as A dot B is equal to the magnitude of A times the magnitude of B cosine of theta, where again, theta is the smaller angle between the two vectors, not the larger angle, but the smaller angle. And we notice that this is consistent because now if we look at A dot A, we say that this is telling us this is the magnitude of A squared times cosine of theta, but of course A and A are in the same direction, so theta is equal to 0. So this is just the magnitude of A squared. So this is consistent with the other definition. So in the next video, we're going to look at some of the properties of the dot product and how you'll be using that shortly.